Alright, so today I want to briefly talk about what we are going to be moving into. If you remember yesterday, we were working on simplifying simple rational equations, where we had to factor the top and the bottom of an equation and then simplify. So today we are going to move on to both simplifying and adding rational expressions. So for example, what I'm talking about is yesterday we would get some type of equation like this, and we would determine whether or not we were able to simplify it. Now this one is not able to be simplified. We can't factor the top, and there's nothing we can bring out of the bottom that would help us, so this would have been our answer. Now, in Algebra 2 you learned about this, but it is something that we will have to review because it is something that is important for pre-calculus as well. So say that I had this expression and I wanted you to add it to this expression. Okay, now at first it looks super complicated, but this is the reason why I had you do the bell ringer where you had to convert fractions. So we know that in order to add a fraction by hand and not in our brain, we have to make our denominators the same. So I would make 1/2 2/4 so that I would be able to add it to 3/4. And we got our answer as 5/4. So whenever we are adding these simple fractions, we have to make sure our denominator is the same, and then we add our numerators. The same exact principle goes for these more complicated rational expressions. So the first thing that we're always going to do is make sure that our denominators are the same. So we check to make sure that our denominators are the same. And in this case they are. So first step, check denominators. They have to be the same, just like in a fraction. We have to make the denominator the same in order for us to be able to put them together. So since our denominators are the same, okay, we don't have to do a second more complicated step. All we're going to do is just add our numerators together. So make sure that if you have a negative right here, that you distribute your sign, but right now we don't have to worry about it because it is a positive. So let's focus on the top. We know our denominators are the same, so we can add our top together. So it's going to be u minus v, that's our first term, plus 6u minus 3v. Now the reason why I kept my minus is because it's addition. I'm only going to change the sign if it's subtraction, because a negative and a negative make a positive. So now I can simplify this expression. I can combine my u's. U plus 6u is 7u. And negative 1v, remember that there's an imaginary 1 in front of this. Negative 1v and negative 3v gives me a negative 4v. So that is our numerator that we've just simplified, and we keep our denominator the same. Notice that when we added 2/4 and 3/4, we didn't add our denominators together. We keep the exact same denominators. 4 stays as 4, and we only add the top. So the same is going to go for here. 8v is going to stay 8v. We're going to keep it like it is. So you can keep it in this form, or we could simplify a little bit further and say 7u over 8v minus 1 over 2. Yeah. Because our 4 and our 8 would cancel out because 4 goes into 8 2 times, and our v's would cancel out. So either one of these answers are acceptable. Alright, so that's when our denominators are the same. Now, the natural question is, well, what do we do when our denominators aren't the same? Okay, so let me give you an example of that. Let me give you the rational expression 6 over x minus 1 minus 5x over 4. Okay, our first thing that we always do is check our denominators. So I'm going to write that down here too so we can see it as we go. And I'm going to abbreviate it as DEN. When we check our denominators, we see that they aren't the same. So it's like, where do we go from here? Because we know, because of our rules of fractions, we can't move on until we convert it somehow. So my question is, well, how did we make this 2 a 4? And how did we make this 1 a 2? Well, we decided what we had to multiply 2 by to get 4. I have to multiply 2 by 2 to get 4, and I have to multiply 1 by 2 to get 2. So we're going to apply that same principle to our rational expression. So if I check the denominator and they aren't the same, I'm then going to figure out what each denominator is missing from the other. Figure out what each denominator is missing from the other. So x minus 1 and 4 are my denominators. What is over here that isn't over here? A 4. Okay? And what's over here that isn't over here? An x minus 1. So what we're going to do is multiply this side by 4, and we're going to multiply this side by x minus 1. Top and bottom. I'll draw it like this so it doesn't get confusing. Because what we do to the bottom, we have to do the top. So I looked at this denominator and I said, what does it not have that this one does have? And it doesn't have an x minus 1. And this side doesn't have a 4. So I'm going to multiply that out. 6 times 4 is 24. And 4 times x minus 1, I'm just going to keep that in its unsimplified form because we might be able to cancel some stuff out. And then we have this side. So we have 5x times x minus 1. And we have 4 times x minus 1. Now we're going to go back to step 1 again. Are our denominators the same? Well, now they are because we multiplied. So now I can do the exact same thing I did up here. I can complete my subtraction with my numerators. So I'm going to say 24 minus 5x times x minus 1. And on the bottom, I'm just going to have 4 times x minus 1. Now at first glance, I don't see anything that I'm able to simplify, so I'm going to go ahead and multiply this out so that I can see if there's any way for me to simplify farther. So right here, I'm going to distribute my 5x across my parentheses. So I say negative 5x times x is negative 5x squared. And I say negative 5x times a negative 1 is a positive 5x. And on the bottom, I say 4 times x is 4x. And 4 times negative 1 is negative 4. Still not seeing anything I can simplify yet, except I can factor, which is what we don't like, but which is what your homework was on. So if I rearrange this, it now looks like it's in its standard form. We put our highest term first. So let's see if we can factor this. You'll get some factoring review too. I'm going to flip over to the back and copy this equation down. So let's see if we can factor this. Let me grab a calculator. So when we factor, our first step is to multiply our first and our last terms. So 5 times 24 gives me 120. And then we take our middle term and we bring it down to the left side of our chart. So I'm looking for two numbers that multiply together to equal 120 that will add together to equal 5. I'm going to start with 12 and 10, and I'm going to go backwards from there. So 120 is also divisible by 8. It's not divisible by 7. It's divisible by 6 and 20, which still doesn't work. And I think we're actually 5 and 24 works, but that doesn't help us. 4 and 30 works, but that also doesn't help us. So this is not easily factorable, which means we are going to keep this answer as it is. It's not impossible to find the solutions. We could use the quadratic formula, but at face value, we cannot bring out a GCF and we cannot factor it. So we're going to keep it in this form. And I'm going to look and see what form they wanted you to put it in on our answer key. That's exactly how they wanted it. So this is as far as we can simplify it. All right, if that was a mess to you, I want you to rewatch it, because this is what we are going to be moving into tomorrow. So if you need to write this down or take a picture of it or go through it again or write it down, I already said that, but write it down. Make sure that you at least have this background knowledge so that when I introduce it to you tomorrow, we're not starting from scratch. So your only assignment is to finish factoring your factoring worksheet. And then I'm going to give you a problem for you to do and see if you can do it. Okay? So I'm going to give you the problem. Trying to find an easier one. 7/3. I don't know why my computer's glitching, so just ignore it. 7/3 minus 8 over 12x minus 8. So I want you to try that problem. Our denominators aren't the same, so we're going to have to multiply each side by what the other's missing. So this is what I want you to do for your homework. Okay? Come with any questions you have tomorrow, and we will continue this lecture and do some practice together.